This is the fourth video of the section, Smoothing Time Series. In the previous video, we decomposed time series data. In this video, we introduce how to use the Holt-Winters function to smooth time series data. Time series decomposition allows us to extract distinct components from time series data. The smoothing technique enables us to forecast the future values of time series data. At the most basic level, smoothing uses moving averages, which average historical observation values to calculate possible future values. In R, we can use the Holt-Winters function from the stat package to perform time series smoothing. The Holt-Winters function contains three smoothing methods, which are simple exponential smoothing, Holt exponential smoothing, and Winters exponential smoothing. All three methods use the same function, Holt-Winters. However, we can invoke them separately based on given alpha, beta, and gamma parameters. Simple exponential smoothing is performed when data has no trend or seasonal patterns. This method can be represented by the following formula. In the preceding formula, the prediction value is f, the observation is x, the weight is, which is a value between 0 and 1. From the formula, we find the simple exponential average is a type of weighted prediction. One can make a forecast based on observation samples and previous prediction values. To use simple exponential smoothing, we need to set beta and gamma to false in the Holt-Winters function. If the data has a trend pattern but does not have a seasonal component, we can use Holt exponential smoothing. This method estimates the level and the slope of a given time series. We can represent this function with the following formula. Forecast equation, level equation, trend equation. The formula for these are shown here, where S denotes the estimate of the level at time t, B denotes the estimate of slope at time t, alpha is the smoothing parameter for the level, and beta shows the smoothing parameter for the trend. Both alpha and beta are between 0 and 1. To use Holt exponential smoothing, we just need to set gamma to false in the Holt-Winters function. However, if time series data contains both trends and seasonal patterns, we can use Winters exponential smoothing to estimate the level, trend, and seasonal component, where S denotes the estimate of the level at time t, B denotes the estimate of slope at time t, I denotes the estimate of the seasonal component at time t, alpha is the smoothing parameter for the level, beta shows the smoothing parameter for the trend, and gamma denotes the smoothing parameter for the trend. All three parameters alpha, beta, and gamma are between 0 and 1. To use Winters exponential smoothing, we need to set alpha, beta, and gamma equal to true in the Holt-Winters function. First, we use Holt-Winters to perform Winters exponential smoothing. Here's the output. Then we plot the smoothing result using plot function. Here you can see the output of the Holt-Winters filtering. We can now find the sum square error of the model. Let's do that. The error value is 79817.9. Besides using the Holt-Winters function from the stat package, we can use the FPP package instead. The FPP package contains many prediction functions from time series and the linear model. You can also find Holt-Winters function in this package. First, we install and load the FPP package. Since I've already installed it, it's showing a warning. But in your case, it will show a successful installation. We can then smooth the time series data with the Winters algorithm. And here's the output. Lastly, we can plot both the original time series and smooth time series. We'll first plot the original time series using plot.ts, and then we smooth the time series with lines. and the color is red. And you can see the change in the output. In this video, we smoothed time series successfully. Impressive! In the next video, we'll perform forecasting of time series.